Hel- Uh, Hello, everybody. Good afternoon. That was nice, and I'm going to give you a smile because even if you're having a hard day, maybe you want to give a smile to the people. As long as it is not too fake, because fake is very easy to spot. So no fake. Okay, and yeah, let's get started. I didn't want to do this today, but let's do it anyway. Because even if you are a low energy, I don't know, just let's be here for 1 hour. With that being said, let's put this thing. Oh, we can subtract 1 minute and be 1 hour here. So wait, let's add that minute back because we will be setting a lot of things. Mhm. Mm, I will say it. Around. Yeah, the projective geometry. And let's go this. Let's go here. Since I don't have my glasses here, I will try to be 1 hour without the glasses and going like this whenever it is necessary. So don't be afraid if I close my face to the camera. And um, then let's open the chalkboard and screenshots. Blackboard copy. So this is the one. Should be called chalkboard. Now we are able to draw. Look, how this software is building. Well, we are having a hard time with just rotating a point. Imagine working in this thing and hey, do the drawing. Okay. Uh, um, so yeah, yesterday we were saying that we have this, we have some circle, you know, and then we have some points, and we realized that geometry by itself will not will not suffice the tasks that we have at hand, the problem that we want to solve. And we ended accepting the truth that we don't remember geometry. And early this day, I was about, let's put some here, over here, This guy is happy. Everybody's happy when you cut your hair in a certain way. You will be happy. Don't worry. This guy likes to use it. Wear it like this. Okay. If you find yourself making drawings in your notebooks, maybe you are procrastinating from the real thing. So be careful. Or maybe you enjoy drawings. So anyway, uh, uh, yes, we are in the accepted the truth, and then I opened the book, the trigonometry book, uh, and I started to understand the thing. But I said I will document the thing. So I decided to. I don't know why to do it live. Read the book live, even if I don't have enough space. Now that this thing is, you know, my father will be mad. He didn't like for the books to be mistreated. This is my book. I bought this book, but still, he didn't want for any book in the world to be, you know, should take care of the books. Uh, so okay. So when I found this unit circle, and the thing started to make sense. But I will read it for you. But I don't know where to put this thing in order not to be like this. This is nonsense. Believe me, I don't know why I'm doing this. uh, Instead of just reading it on my own and then come back and show you the code instead of having you seeing me doing this. I don't know. But this is how it is. I wanted to portray the thing. So a, a there is this thing, and then there's the origin, and then there is a radius of one here, and they mark the positive direction, which is great because you learn about this in some other books. Another, and then we have this coordinate for this point, 1, 0, and then there is. How should we will be able to do it? Okay. And remember, we found this equation, and it's here also. This is the unit circle because it has radiuses of 1. I'm not going to write everything. And then Oh no, this arrow is not part of the axis. This is some angle. Some angle. This is X, Y. Now look, this is an angle. They like it to call it like this. And then there is this thing called arc of length S. This is an arc of length S. And then it says that, let's use this, that X is equal to cosine, which we don't know what it is. I can tell you that it is a relation between some types of a kind of y equals 10. I don't remember precisely what it is. There are some mnemonics that I read somewhere. But what's the point? Right, let's see how these things are built. That's why I really enjoyed that geometry book because they don't. They it's not about memorizing. It's about how the thing is being constructed by primitive uh, elements or yeah, by, with the elements of the constructions. I would like to approach trigonometry in the same way, if it is possible. I don't want just to see something, hey, memorize this because it is like this is the hypotenuse, this is, I don't know. Then I will say, why would I do that? I'm not even in the school. I want to see different, I wanted to see, you know, why do we need to study this? How, you know, what, what things were they solving? And then they say, here it is, X, Y, the coordinate, we need this. But for ourselves, we will start at this point and move over here or here. So we will need to adapt all of these things. It's not straightforward from the book. Uh, so this is how X and Y are calculated. Cosine of S and sine of S. You know, it seems so easy. But maybe there is something. And then it says that if theta is measured in radians, then the length of the arc S is equals, and they give you this thing. Now theta is on radians. We need to see what's that, the conversion to degrees. And yes, we have the radius, which is the midpoint. We have theta, which is the rotation. And then we can have this thing, S, by multiplying these two, and then use the libraries in JavaScript to calculate the cosine and sine of S, and maybe write this. It seems so easy. And they are starting from here. No, they are not starting from the midpoint. And we need something similar, but we need to start from here because our straightened edge uh, gets the origin is here. So we need to perform translation. And then this is the radius. This is some point. Then move it. Not this point. This point. That will be something to consider. It to move this point instead of the of here. So we will need to really dive in a little bit more into this. I think the thing is has started to get clarified, and let's try some calculations with this. But we don't know this S, but we know that there is the 0, 1. This point is here, and this angle is 90 degrees, but not radians. So we have something to work in here. With that, we can calculate this arc length. Since most likely they already said how to convert from degrees to radians. So it says radian measure. Conversion between degrees and radians is chapter 3, 100. There is this note, there is a book mentioned how to solve it. Oh my god, this is becoming cumbersome for me. Angles can be measured in degrees. No theoretical word mathematics, radian measure of angles is preferred. And the justification for radians is that the functions and the range for the trigonometric functions, um, the domains can be the real numbers. So converting between degrees and radians. Multiply a degree measured by pi over 180 radian and simplify to convert to radians. And then there is this thing. In order to in order to uh, to convert from degrees to radian, you multiply the degree times pi over 180. We want to convert, and there is an example of 45 degrees. That's the number 4 times pi over, and the result is pi over 4. But then someone will say, oh, I don't get it. Why is this? And you should multiply 45 by pi, and it is, I mean, it's 45 by this fraction. This is a fraction. Okay, and the answer will be 45 pi over 100. Like I said, there is a 1. Okay, and someone will say, very sad, I don't believe you. And then you should be able to know that there is a 1 in here. If there is not a 1 in there, you can't write it. because 45 over 1 is 45. It's the same number as 45. And you do it for convenience. And eventually you can forget about this number. Now you can multiply. And you know how to multiply brackets? These two and these two. If this is one, this remains the same. This is extreme procrastination. Now that you have 45 over pi over pi, 45 times pi over this number, maybe you want to know why, but that's up to you. Um, why the things are as they are is up to you to go further or divide it by yourself. So you get to write this into 45 is for, maybe you can simplify it. When you get this fraction, which is this, but we calculate 90 degrees. So 90 degrees will be pi over 2 because then 90 degrees is past 45. So you get these two instead. You can even divide 180 over 90 and you will get this. This is not on the book, so I know one thing about fractions. Just a little. Uh, what else? Well, that's it. I hope the alarm sounds and we can leave the session. I'm messing with you. Okay, so this is the rate, the degrees. We have theta in radians now. And we have the radius, which is 1. So S will be uh, P over 2. So, and this is too much for me. So I'm using the calculator. What is P? P, pi. Look at this. Over 2. So apparently, this arc, this yellow arc, its length is approximately 1.5. Do you believe that? Well, this thing, it's 1. So it's possible that this is 1.5. It's possible. But now, to really verify this thing, we are going to use this as this number and calculate the 0 and the 1. And then we should use these two, cosine of s, sine of s, and we should get 0 and 1. But I don't see any sign over here. And remember, I don't have my glasses, so let's use the scientific. Oh, we are in the scientific trigonometry. Sine, and it's 0. And this is not 1, it should be 1. And then let me go back to this thing again. P over pi over 2 over 2. And then just cosine It's almost one. So it's switch. So we need to find out what's really happening here. If we did something wrong, most likely that's the case because this should be manipulated, switch because um, I don't know. Let's continue. So now we have this. Okay. So the radius is on. So it's the same. This is the same. But let's see what we can change to have different results. You know, the thing didn't show what we want to see. We need to change something to see different things. But what can we change? Mm, okay. Uh, Let me think. Now we want, okay, let me trace back all the things. We have this date, we have this radius. We can calculate theta to see if we have pi over 2 or 90 degrees. And that will be the arc, the length of the arc over radius. Okay, theta is the length of the arc over radius. This thing just went here. Hello. Um, this is nonsense. But still we're going to do it. So we have this. You see, this is nonsense. Wait a minute. This is S over 1, which is the same. And since this is a little bit difficult. Now let me see from radians to degrees. This should be multiplied by 180 and then divided over pi. And look, this works. This is 90 degrees. Look at this. So we calculated, we have this S uh, is correct. But we want to find this x and y. So we have to see that this 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 length is 1.5. This is what the book says. The book also says that if you apply the cosine function, I'm talking like from the programming perspective, if you apply the cosine function to S, you should get X. Which is 0. Okay, so this thing works as long as the thing is on degrees. So maybe the cosine and the sine works in degrees. Okay, then it should say cosine of theta instead of S. Maybe the same. So this thing works as long as you are applying these two functions on not on S but on this angle in degrees, not in radians. You saw the thing. Minus 1. So it will be minus 1, 0. I'm going to try with this. This is an angle of 180 degrees times pi and then the same number. So this is pi. Um, so S is pi. Okay. This is almost one, but it should be negative. So let's use this one, and then I don't know, and then the sign will be 0. We are just tackling the surface. Maybe we are missing something. Okay, but so far this thing works. As long this is theta for us. In the book, it's S. Maybe we did something wrong, but for us, this work. If it is the angle and it is on degrees, but this is for the unit circle. Now let's try a bigger circle or continue with the reading. It's up to us. Let's suppose we now use a radius of 2. This will be this will be if we use a radius of 2, it will be 0, 0, 0, 2. 0, 2, 0, 2, 0, 2. Okay, radius 2. So it will be this. This is, I don't know, this is a little bit silly. So now the arc length it will be the degrees in radians, 90 degrees times 2. These two, we get rid of it, and it is pi. And then this thing will not work anymore because we have the same angle. It will tell us that it's 0 and 1, 0 and 1. And now we need 0 and 2. So let's use the arc length, which is 5, which is, you saw it was like this. Pi resulted in here. So maybe there is a connection between this radius being 1 and this. Now it's 2. But now this 2 is going over here. And maybe for a unit 2, it's 180 degrees. So anyway, let's try with pi. So we're going back to S. So it's pi sine. So there is something wrong. We are doing something wrong. So the one thing we should do is to continue reading. This was just the surface. Just this figure and this paragraph. And we did all of this, so maybe we missed something. So let's continue with the reading. Don't dismay. That's not true. That's not the paragraph that we saw. We were seeing this page. Yes, this is the one. You know, this is the figure, and then this paragraph. Okay, the radian measure of theta is related to the arc length S. For theta is measured in radians on R and S measured in the same linear units. And that's the formula. And it goes even simpler. If the radius has measured 1, then the thing, the arc length is theta. Then thus the trigonometric functions of angle theta in radians found by choosing a point xy on the unit circle can be rewritten as functions of the arc length s. The following functions are defined for any real number as represented by a directed arc on the unit circle. This is this is something different. the point gets selected by us, and then we can know, and then these trigonometric functions are defined, can be found, can be calculated. And then there is a circle with lots of, but this thing doesn't seem to follow a pattern. If you observe this picture, mm, yeah, maybe they are. Maybe there is a pattern. Mm, Just in relation to the quadrants, this thing repeat. For example, 120 degrees with 240 degrees. These things seem to work. But uh, in order to perform our calculations, these coordinates over here are quite, uh, uh, you know, these are not, how do you say, integers like this. These are real numbers. So we don't know for sure what's this point, for example, the coordinate of this point. Unless we use this, but we are trying to verify these things. So we need to know in advance this to see if these things. Uh, will work for us. I don't think these guys. There's something wrong in here. They are mentioning these equations, these equalities, so you can calculate the point over here. Let's suppose this is 25 degrees. According to them, the Earth is um, is this angle for in radians. 45. Yeah, let's use 45. 45 should be like you. And according to them, 45 is P over 4. P over 4. And then we can calculate this x and the y. 0.013. Zero point 0.99999. Do you believe this? That this is 0.99999. So this is the one. This is the x. So maybe we can believe that this is 0.9999 because of our drawings. Maybe it is near to 1 dx. Maybe we should have used this thing instead. Okay, let's use another color. I can't believe myself. Let's use this. No, this is radius 1. Still is too much, too far. 45 degrees is over here. Oh my god. This is 90 degrees. If we draw a line, if we draw a line, this is too far, you know. This is not 0.9, maybe 0.8. 0.999 is almost one. Should be like here. Maybe I am too ignorant of all of these things. And 0.13, uh, we can believe this because this is one, but still 0.02 should be like here, you know? There's something really wrong in here. Now let's use, you know, the degrees. Measure 45, sine 0.7. That's most likely. I say 0.8. I said 0.8, but it's 0.7. I can't believe that. And what is the other one? 45 cosine. Oh my God. 45, 0.7. It's the same. Yeah, it's possible. Yeah, it's the same number. There's a line over here. Yeah, this is 0.7, 0.7. I believe this. Uh, but the radian thing, it does not work. These are no, these things, this thing doesn't work. Maybe we missed something. But with the degrees, it works as long as it is the unit circle, because we saw that it is radius 2, radius 2 by over 2. My God, radius 2 by, and this is the 180. It's the same number. Almost the same number. Yeah, this thing works as long as this. Um, how do you say? With the degrees instead of radians. Maybe your calculator is wrong because in the book this thing seems to work. Okay, so it's 90 degrees, 180. Yeah, it is 100, 270. Let's try this. 3 times 5. Because the book is saying that maybe they are wrong. I don't know. Sometimes the authors. We need to verify. So 3 times pi times 3 over 2. And this is a number, big number. Let's try times pi. This is different. It's the same number. Okay, so we just divide it first. 3 over 2 and 10 times pi. And they say, okay, Apparently, they say it isn't the book. I'm not messing with you. They say that sine of this number it's -1. And look at this. This is not -1. So this calculator is wrong or the book is wrong. Or maybe I'm not, I don't know how to use this calculator because it says deck and maybe I should choose whatever it is. Let's try this. There's nothing. Oh, radians. We have to, this is the, oh my God. Look at this. Okay, we have this degree. We need to check this. Can't believe it. Okay, you can change this whatever this being gradient or I don't know, I don't care. It was like this. Now we have clicked the thing, you know. It's hard to design user interfaces. Okay, we were like this, and look at the result. Mm, 1.5 times pi equals this number, and then sign, and it says 0.08, blah, blah, blah. Okay, whatever. I do care. That's why I'm doing this. So now let's click over here. Radians 1.5 times pi. It's the same number. Now sign. And we got it. I'm feeling like, I'm feeling like throwing this thing through the, like, or through the screen. Oh, and I was about to finish this, uh, the session by saying, what's wrong with this book anyway? I have sent some errata to some authors, and they have accepted the suggestions. But at some point, I say, "Oh, come on, I can be correcting." It's not the case that I have corrected like a zillion of books. Okay, but I always have my doubts about what gets published in the end. But in this case, I knew something went wrong with this calculator, or probably with the approach we were trying. And yeah, I was about to open Java, and look for the functions in here. So this is kind of a thing if you are developing a some library devoted to mathematics, because look at this. A shell. This is Java. I mean, you can use Java, and you have the math library. And imagine you get hired, and they say, okay, now the the sine and cosine functions in the math class are not working at all. So take a look. And then you get this sign, that sign. And then you have the documentation. Okay, and then we read an angle, and they specify in radians. So in here there is no such a thing. Okay, it's up. You are one. I like Java because of this. They are very in their documentation. They have a great specification. How can I say it? Yes, the API documentation of Java is great, and a very cool piece of software engineering on the JVM and its documentation, the API. So there is no thing, no space for confusion, right? In radians, you give me the radians. Stop with the degrees nonsense, right? And if you open other classes, uh, you can go a long way just to read it. I like it that from the very beginning because they say just give me this exact in this fashion, and I will produce this for you. So you don't care about how they do it, all right? You don't need to read anything. You just need to read uh, the specs, just even the signature. I don't care. You're telling me you need this, and you're giving me the answer. That's amazing. Okay, so now we are here. Now we can recalculate everything that we have. We were trash talking this, but look at us doing some, how do you say, Scrabble? How do you say, Scrolls? I found this word in my readings of the Lord of the Rings. The Lord of the Rings. Those English. Scroll. Scroll. This is a scroll. Maybe not. It is just a scratch. Maybe this is a scroll. No. What's scroll anyway? Writing my name in this fashion? Because this is how they were doing scrolls on some stones in the book. Okay, now in, uh, I said 1 hour. Let's recalculate the 45 degrees in radians to find 0.77, 0.7, and then leave. Maybe this number, 180 degrees instead. And 180 degrees was pi. So let's use pi, and we should be able to find -1 and 0 cosine of s. We use sine. Well, we are now using pi for 180 degrees. Pi, and we need to apply cosine, and it's -1. Look at this. Okay, and pi again, sine 0. Yes. Okay, now let's try with 45 degrees, which was pi over 4. Okay, now let's apply. It was at the same level, so it doesn't matter if you apply sine or cosine, but let's sine. And look at this, how beautiful this is. Don't sine, let's cosine. Or use sine and cosine at the same level. Uh, yes, okay, we finally learned something about this thing after many years. So that was great. 1 hour a day, learn something new. Uh, there's no time wasted if you engage into any study, whatever you like. You will get something, just a little, and that's enough for the day to be worth. Okay, so I was hesitating today, but at some point I say, well, maybe I was hesitating because of the ignorance of my ignorance of this. But at the end I said, well, in any case, I want to build this thing. So radians, learn the user interface of your calculator, learn to use your calculator, explore your calculator, be happy. Uh, what else? Now we have unlocked. We have turned a little light in the darkness, a little lamp. We have more light. Uh, we will continue. It seems now that we can go back to this point. So since it is the unit circle, oh, now we can have everything in here. Remember, radius 2, we we said, oh my God, what is this? Uh, so radius 2, so it will be 2, and here we arrived to the same thing. We arrived to the same thing because 90 degrees is pi over 2, but we are multiplying by 2. So in the end, it's just pi. I'm going to finish today and tomorrow. Let's start tomorrow with this. Why should I wait until tomorrow? Why not fail today? Let's fail. Okay, so okay, pi, and we are already seeing that even in radians, pi will give you this, and we need this. So radians pi over 2, pi over 2 times 2. Let's celebrate failure so we can recover very fast. Times 2. You see? Well, now we are going to use the sine and cosine, and we will not get this. We are getting this. You see? What's Why do you think? What do you think should be changed? Does this thing only works for the unit circle? A lot of questions can be derived. Uncover the truth in the upcoming episodes. Stay tuned, and we will solve this, even if it's unrelated to our problem. Because now we want to know, and we will know. So thank you very much. So don't be afraid of failure and ridiculize yourself. Hey, this I don't know anything. Just never mind. Okay, we will uncover this in the upcoming episodes. I think we're ready to go. I don't want to read this book in this fashion. Maybe I will take a look on my own without, but I will inform. I will tell you. Uh, I'll read the book because it's too. I don't know. Or maybe I will do it anyway. I don't know. Then we will use the open stacks, the rotation thing. But I think we should be able to. If we find why this thing is not working, then we should be able to derive it by ourselves, the entire thing. Uh, so this is related if we want to find it by ourselves, because now we can have any radius and how it connects with these things to get and the coordinates. In this case, 0 and 2. So it is related, and if we find why, maybe we are done without taking a look at the rotation topic. Maybe we should find out. So I feel better. If you're feeling low, do mathematics. There, mathematics will always bring you some life. Be sure to be honest to yourself and grab the thing that you are, you know, maybe maybe I want to review counting. I'm not talking about you. Maybe you're an expert. But in my case, I have to be honest with myself and tackle topics that are challenging but not too crazy. And then you will gather some energy to continue in your journey and know and don't feel, oh my God, this is not for me. There's nothing here for me. There's something for you. Do mathematics and be happy. Thank you very much. Bye.